Hello, this is Valhalla from Facts from Friction, and this is a debunking, I'd say, of Randy Flat Earth, or rather to answer his question. How is it possible that we cannot see from Blackpool to Snowdon Mountains, or the Welsh Mountains to be more precise? And he posted a video recently about how is it that while um, shooting in 4K, we cannot see it. Well, the answer is quite simple. As you can see from the screen, I made a quite realistic to scale the distance to between Blackpool and Snowdon, which is about 100 kilometers. And as we can see, there's a quite going on. Some of you probably, and hopefully the flat earthers, don't understand that the premise that Randy has is that how is it possible that we cannot see the mountains? Well, if we are on a round object, well, wouldn't it be more prominent that we are if we couldn't see them? If we can't see them and we are on a flat surface, then it makes no sense. Okay, if we aren't on a flat surface, what can be on that? Well, of course, globe or sphere is the most common answer that would be. But from his standpoint, he tries to prove that Earth isn't flat, isn't a circle or sphere, but is a flat. And indeed, he tries to make the same point, which would be more visible if it was a flat surface, if Earth was a flat surface. So what I did, and everyone should, everyone that understands facts and understands how math and proportions work know this. It's not the rocket science. This thing. It's just basically okay. You have 100 kilometers. What can be your scale? Okay, you cannot say, oh, this is the angle. Why? Because the angle will change. If you use different scales in different planes. So what I did was I tried to make it to scale. And unfortunately, there are some limitations in Photoshop that I wasn't aware of. And apparently, you can do maximum of 64,000, if I'm not mistaken. Yeah, or maybe 300K. I'm not sure which it was, but I could actually do an Earth diameter of 1.274 million pixels, which I wanted to do. So unfortunately, I only have a take 10K screen, which shows realistically the drop, which is about 750 meters, depending 750, 770, depending on the initial position where we are standing. But as you can see, 1 pixel in this representation means 10 meters. So even if we are 10 meters above, it means just simply 1 pixel. And this isn't 100%. We can see it. And if we want to go for real size, this is a 1 pixel. And it's not even 1 pixel. 1 pixel will be 1 point here. So even these lines are think they're like 30 meters, would be. And when we look at it, he's standing somewhere here near mirror. And if we look at how far it will be, sorry, it takes quite a bit to load it here. We can see, okay, realistically, he should be able to see something. But at the same time, we're living on a planet with an atmosphere that we breathe, so we can live here. And unfortunately for him, this atmosphere causes a refraction. So objects that are near the atmosphere cause them to basically disappear or not being visible. Of course, that's not everything. When it comes to light from the sun, actually the atmosphere has the opposite effect when we can see the sun even if it's beyond the horizon. But as you can see here, this is 750 meters at 100 kilometers. Look at it. It's about 100 pixels. It's about 100 pixels. When we look at it, okay, it's 70 pixels from the theoretical flat line, a flat horizon line that should be visible. This red line is what we should see on a planet without an atmosphere that has the same dimensions as Earth. But we have atmosphere, so cannot be done. And if this was a flat Earth and there was no atmosphere, we should basically see everything. If there was a refraction index, which, okay, yeah, sure, why not? We should actually see uh, some of it as well, since the refraction index, if it was the same, which is worked for spheric objects rather than a flat line, it would be probably something around here as the red line, something similar. But as you can see from this simple demonstration, that is to scale, and this is the profile from the black pool to the Snowdon Mountain. This is a profile, So yes, what he says is true. We should be able to see something. However, that's before we take refraction into account. So what he says, oh, well, I have a 4K camera. Well, 4K, when I did some math, it was 1 pixel was equal to about 1 meter with 3000 focal length. 3000 millimeter, 35 millimeter equivalent focal length. That is used, on regular cameras. So he has 24 to 3000 millimeters. So when he was recording the video, even if he was zoom maxed in, it would be 1 meter would be 1 square meter would be around 1.5 pixels. And from this, it would be quite a lot, And even then, you would have like a 50, 100 maybe pixels on the width that you would see it. Because there would be like 200 pixels somewhere here. I think it would be like 200 pixels here. That would be it. Unfortunately, refraction is son of a bitch. So yeah, you cannot see it. When I was drawing, I realized afterwards that I should actually include the C, the Irish C. So this is just a simple representation where it should somewhere end and start, near Blackpool. So this is not, the precise. So it's only a representation. So you actually can understand, okay, here starts, the C, or maybe it should be slightly more here. I'm not actually quite sure where it started, but I think I did it correctly. So yeah, this here starts the length again. This is the profile that I've generated from Google Maps, from one of the that can generate profiles. And when I was looking at it, there was actually a function that allowed you to see on a curved Earth, and even what it was visible, and it was showing that it should be visible. Maybe these stops could be visible, but not without refraction. So yeah, unfortunately, he doesn't have any points that could survive, uh, more precise scrutiny. And this is not even 100 kilometers, it's 105, 106 kilometers when I was looking through it afterwards. But it's rounded, it's rounded. It's not precise, but it's precise enough, It's not something that has like 50% difference, but it's still within a reasonable margin of error. So yeah, I will include this fact sheet, or as you can see it, in the description, the full 10K pixel, size. It has only 1.4 megabytes, so it should be a problem. But as we can see it from a simple demonstration, why we can't see the mountains, the Welsh mountains? Well, because they are beyond the refraction. And this is the scale. It's not exactly 100% correct, don't get me wrong, but it's like 98, 99% correct when it comes to it. Why? Because if I wanted to be more correct about this, well, I would need more memory, and in Photoshop, and it wasn't complying. Well, it's too much, and even generating some of these things was quite pain in the bottom. So yeah, hopefully guys you like the video, and hopefully you will enjoy this video and other videos that I'm going to make, since I'm getting frustrated with people that doesn't understand basic knowledge, basic math, basic problem solving. And well, it's not up to scale. Well, a lot of things should be up to scale, otherwise you get people that think, oh, it's not up to scale. Well, it's fucking madness. So sorry for rambling. And once again, if you like it, give it like. If you like it, subscribe. I will make another videos in the future, and hopefully try to bring more reasonable debate into this topic and other topics.